Yeah, so we look at this first one. Trevor said aluminum sulfide. So, if I back up a little bit, let me write it a little bit different way. Every ionic compound is made of a cation plus an anion. Okay? Meaning a cation, think of that little lowercase c, that's a positive sign. Every ionic compound is made of something that has a positive charge. That should not be in blue. Let me do that in red. Okay. Every ionic compound is made of something with a positive charge plus something, plus an anion, something that has a negative charge. Anion, think there's like those two N's there, N for negative. Okay? With an ionic compound, it's generally going to be a metal plus a nonmetal. So if you look at this first example here, aluminum, that's a metal, right? If you remember the organization of the periodic table, that's a metal. The metal comes first, plus the nonmetal, in this case sulfur, and then, but you don't say aluminum sulfur, you drop the ending and you put I. So it's aluminum sulfide. So you drop the UR of sulfur. All right. So then, if we do the other way, we go to number 2. How would you write the chemical formula? So kind of like this, but for potassium iodide. What do we think? No, we think no. Ki, yeah. So K, I'm writing it in red because K is the cation, it's the metal. I am writing in blue because it's the anion, thank you, it's the nonmetal. Now, whenever you write the chemical formulas, you have to remember that the charges must balance. So charges balance. What I mean by that is the charges have to equal 0. The charge on the cation and the charge on the anion have to add up to 0. So the reason why it is 1 K and 1 I is because each K forms a +1 cation. You know that because K is in group 1, everything in group 1 forms a +1 cation. I is iodine. Iodine is in group 7 or 17, and it's going to form a -1 anion. Okay? 1 minus 1 is 0. Okay? If I explain to you here, well, why is there 2 aluminums and 3 sulfurs? Well, let's look at the charges. Aluminum is in group 3, so it's going to have a +3 charge. And it says there are 2 of them, so 2 plus 3s. Sulfur's in group 7 or 17, or I'm sorry, group 6 or 16, so it has a -2 charge. And there are 3 of them, 3 minus 2s. Well, 3 plus 3 is 6. -2 minus 2 minus 2, that gives you 0. Okay? Charges have to cancel. All right, coming down here, rubidium oxide. So how would I write the chemical formula for that name? Sorry, go ahead. Yeah. RB2O. Yes, RB2O. Good. So how Tara knew that is, well, rubidium, that's a metal, so it's going to go first. It's a cation. Rubidium forms a +1 charge. All right. Oxygen is in group 7, or I'm sorry, group 6 or 16. It forms a -2 charge. As it stands right now, 1 minus 2 does not equal 0. That is why we needed 2 rubidium atoms. We needed 2 +1 charges to cancel out the -2 on the oxygen. It really is, I think this is really simple. Like where things can start getting confusing is once we get into like the rest of the ionic naming and then we do covalent naming. People begin to like forget to look at like, I don't know, we'll get there when we start adding on some other levels of detail, but the basic idea is really not that complicated. It's fairly simple. All right, doing the last one, CaCl2. How would we name that? Go ahead, Carl.
Calcium chloride.
Calcium chloride, good. Calcium, you always say the full name of the cation or the metal, and then you wouldn't say calcium chlorine, you drop the ene and you put ide, calcium chloride. So, there you go. All right, so then getting your notes out. We're going to go through 2 sections of notes today. So we're going to go, and I showed you this slide last class. It's kind of a good summary slide. So basically, I'm going to explain to you this whole slide today. So at the end of today, you should be able to look at this slide, and it all makes sense to you, these different rules here and there. All right. And same with this slide. So, all right, so how do you name ionic compounds if the metal in the ionic compound is a transition metal? And it's just a little bit of a wrinkle. It's the same basic idea. It's just kind of a little bit of a wrinkle. All right, whenever we went over electron configuration, like if you did the electron configuration of, say, let's say we did aluminum right here. Aluminum's electron configuration was you could do the nearest noble gas, which was neon, and you would go brackets neon, and then you would go over here 3s2, and then over here 3p1. You don't have to, know electron configuration for this, but what I'm getting at is if you did the electron configuration for, say, titanium, the nearest noble gas is argon. So you could say brackets argon, and then you go here 4s2, but then something weird happens. You now, instead of saying 4, you say 3, because now you're entering the d orbitals, and the d orbitals, where you get to the transition metals, the d orbitals are actually at a lower energy level, even though they're further along on if you're going left to right, left to right. So what the consequence of this is that the number of valence electrons of transition metals can change. Why that's important is I said that the reason why each of these elements formed the kind of ions that they did all came back to the valence electrons. So the transition metals, the reason why you see these multiple options, like titanium can either form a +2 cation or a +4 cation. Vanadium can either form a +2 or a +3 cation because they can recruit electrons from their 3D subshell. Okay? That's why you're going to get different charges here. So basically, we have to deal with how do I handle the different charges? Because a situation can arise, if we jump to the next slide, where if we combine iron and oxygen, there's actually 2 different compounds that can arise. So if I had iron and I have oxygen and I want them to bond together, iron can form either a +2 charge or a +3 charge. So say you're working in a lab and the scientist you're working with said, hey, we're going to do this reaction. I need you to get some iron for me. You can't just go to the shelf and grab iron. You need to specify, well, am I getting iron that has a +2 charge, or am I getting the iron with a +3 charge? Because how that iron behaves and then the chemical properties of a compound that has an iron with a +2 versus a +3 charge will be drastically different. Okay? So how you name that is actually fairly simple. If I had an iron with a +2 charge, all I do is I wouldn't just say iron oxide like you would normally. You would say iron 2 oxide. You put parentheses and you use Roman numerals to specify the charge of the iron you use to make that compound. That way, so in other words, a scientist wouldn't say, we're going to make iron oxide today, go get some iron. They would say, we're making iron 2 oxide. Make sure you get the iron with a +2 charge. Okay? That's the wrinkle with the transition metals. Now, how that comes into play with, say I ask for the chemical formula of iron 2 oxide, how you know it would just be FeO is iron 2 oxide says that iron has a +2 charge in this scenario. Oxygen always has a -2 charge because it's in group 6 or 16, always has a -2. And 2 minus 2 gives you 0, so it's already stable. So then the other scenario for iron is if iron can have a +3 charge. So you would specify that by saying iron 3 oxide. Don't worry about the ferrous oxide or ferric oxide. I'm not going to make you memorize that. There's just basically it's kind of a name people had called these two different substances before we came up with this systematic naming. Okay, so it's kind of like a remnant of the past. Same with like cupric iodide or plumbous chloride. I actually didn't know that was a thing. Similar ideas. Just people have been calling it that, way back in time. All right, so iron 3 oxide is Fe2O3. The reason for that is iron 3 oxide, the iron has a +3 charge. So you have 2 +3s. Oxygen always has a -2. So then that would add up to 0. All right? And if we look at another example, copper and iodine, copper 2 iodide would be CuI2. Now, what can happen is I could give you this, and we'll give you scenarios like that, CuI2, and I'll ask, what is the name? And what a lot of people are going to do is they're going to say, oh, Cu, that's copper, I, that's iodine, it's copper iodide, and that's not going to be correct. That's where these get tricky, because you have to be able to look at the periodic table and know copper is a transition metal. So I got to specify the charge. I got to put in parentheses what the charge is on that copper. But the question is, how do I know what the charge is on the copper? If I give you CuI2, how would I know if that's a 2 or a 3 or a 1? Millie, go ahead. What do you think?
If you look at the charge of iodine and just
Perfect. You focus on the charge that you do know. Copper is a transition metal, so its charge can change, but you do know iodine. You know that iodine is always a -1 charge, and there are 2 iodines, so you know you have to cancel out a -2 charge to get us to equal 0. And you only have 1 copper atom to do it with. So that 1 copper atom must be a +2 charge. It's like, in other words, it's like a very basic algebra problem, like x minus 2 equals 0, solve for x. It's kind of a way you can think about it. Okay? All right, that's the basic idea. Nothing new here. This is just kind of in words explaining what I already did on the board. Whatever it takes to cancel out the charges of the anion, that's how you figure out the charge on the cation, the charge on that that transition metal. But I'll give you a sec to finish writing that. Are we good?
Yeah.
Cool. Okay, so now what do we do? How do you name ionic compounds with a polyatomic ion? Okay. First thing is, I need to explain what a polyatomic ion is. These are all polyatomic ions. How you know that is poly, that means many. Atomic, that's referring to atoms. Ions is something with a charge, right? That charge could be positive, it could be negative. In other words, an ion could be a cation or an anion. So a polyatomic ion is an ion that is made of multiple atoms. And there's a lot of different polyatomic ions that exist. This is the list of most all of them. I mean, I'm sure there are technically some other ones that do exist. You don't have to memorize this whole list. But you do have to memorize the ones I'm having you write down, the ones that I have in the red box here. Okay? This is where this unit can get tricky. They're using the same rules here, but you have to memorize that nitrate is NO3 with a -1 charge. And that hydroxide is OH -1. Now the names will give you an idea of what they're composed of. Like nitrate, that makes you think of nitrogen, and then 8 is usually referring to oxygen. It ate some oxygens. So, for example, acetate has a bunch of oxygens. Carbonate, carbon plus some oxygens. Sulfate, sulfur plus some oxygens. Phosphate, that's a phosphorus atom plus some oxygens. So there is some patterns you can use here. Hydroxide is OH minus 1. So hydro, hydrogen, oxide, oxygen. Acetate is one that's pretty tricky, truthfully. So it's C2H3O2 minus 1. That's just one that you'll kind of have to work on maybe a little bit more than some of the other ones. Okay. Sulfate SO4 minus 2, carbonate CO3 minus 2, phosphate PO4 minus 3, and then there's only one positive. Only one of these is a cation, and that is ammonium, NH4 plus 1. What do you notice about ammonium? Like if you look at, I said cation, and then right underneath it I said metal. And then look at ammonium. There's a kind of a contradiction. Maybe contradiction is the right word. There's kind of like a incomplete story that I haven't told you about. I've told you cations are metals so far. But if you look at ammonium, what do you notice about ammonium? Like the elements that make it up. They're nonmetals. Nitrogen's a nonmetal, hydrogen's a nonmetal. So all metals are cations, but not all cations are metals. So sometimes you can have the only one that you need to memorize is ammonium. Sometimes you can have a cation that has that's made of nonmetals. So there you go. Yeah, Kelly.
What is the compound for carbonate?
Carbonate, that's okay. It's CO3 minus 2. Yeah, are there any other ones anybody needs here to say out? Yeah. Flashcards work great for this. I made that, like, how I learned these beyond just like it's literally my job to know them and I see them all the time is like when I was like just make some flashcards. Just run through them, you know, every so often, and I'll leave this list up here whenever you're working. That way you can kind of reference it. Yeah. Anyways, no. Yeah. You don't need to know these other ones. It just was a convenient slide. It's hard to find a slide with the ones you have to know without finding ones that you don't have to know. I think it may be kind of interesting to see some of the other ones that exist, but just for right now. And really, like, even if you study chemistry in college, like, they don't make you memorize much more beyond that. I didn't study chemistry, so I can't say that for sure, but when I had, like, freshman chemistry, I think we just had to know this same list that I'm making you know. Maybe, I think there's a few more. I know nitrite was on there. So, anyways. All right, we good? Okay, so then the naming rules, so how you name with, like, polyatomic ions, it's just the exact same rules. What's really, the only thing that really makes it like that difficult is just like, well, now you have to know these polyatomic ions. So if we go one at a time here, Cr2SO43, well, how would you name that? So same rule. So Cr, what is Cr? It's not as commonly used of an atom. No.
What would the answer be? Chromium sulfate?
Chromium sulfate. There you go. So Cr is chromium, and then SO4, that's sulfate. So you just say chromium sulfate. In other words, naming is actually easier than the other ones, as long as you know the polyatomic ions. Because you don't say "ide," because if you said chromium sulfide, that would get rid of all the oxygens. Okay? So you don't change the endings with the polyatomic ions. You just say the name of them. Okay? Yeah.
What is the 3 on the end?
Yeah, all right, so let's talk about, like, if I give you the name chromium sulfate and I ask you to give me the chemical formula, how would you know this? Well, you have chromium, and chromium is a transition metal. So we don't know the charge on chromium. But you do know that sulfate is SO4, and you know, if I go back to that chart and you have it memorized, you would know that sulfate has a -2 charge. So I know there's a -2 charge on sulfate. And I know these charges need to cancel out. So if I go back to this, I went past it. This slide here, this one I technically would have to I'd have to tell you, choose the one with a +3 charge. I would need to say, we would need to say, for this one, we would actually need to say chromium 3 sulfate. We would need to specify that there would be a +3 charge on this. Because if you had 2 +3 charges, and to get to your question, Kelly, this 3, this is saying you have 3 sulfate ions. So that 3 applies to the sulfate here. It's very similar to like that 3 on the O means you have 3 oxygens. But that's why you put parentheses around it. That 3 only goes to the sulfate. This is saying you have 3 -2s.
So the 4 and the sulfate isn't how many atoms?
No, the 4 is just saying that the individual sulfate ion has 4 oxygens. But then we have 3 of them. Okay? Let's see some other ones. So CaNO3 what would that one be? Calcium nitrate, yep. Ca is calcium. NO3, it's one you got to memorize. That's nitrate. Calcium nitrate. Now let's look at, hypothetically, if I just gave you calcium nitrate, how would you know the chemical formula? Well, you know that calcium is Ca. Okay? And you know that Ca, if you look on the periodic table, Ca is in group 2, so it forms a +2 charge. And you know that nitrate, well, you would hopefully memorize, like if you go back to your chart here, nitrate has a -1 charge. So that's something you have to memorize. Nitrate has a -1 charge. So I need my charges to add up to 0. So that's why I would need a second, that's why there's a 2 right there, a second -1 charge. The reason why you have to have parentheses is this. If you needed a second nitrate, you can't write this, CaNO3 2. Why not? What's wrong with that?
You're saying there's 32 oxygens.
Yeah, I'm saying that this is a polyatomic ion that's 1 nitrogen and 32 oxygens. That's ridiculous. That doesn't exist. That's why you have to have the parentheses. Because then what this says is we have 2 individual NO3s. Each NO3 having a -1 charge. That's what the parentheses mean. Okay. All right, you can actually cross this last one off. HCO3, that's bicarbonate. That is a polyatomic ion, but that's not one that you have to memorize. So you just don't worry about that one. We all good in this slide? Yeah. What's that?
Wait, what are the like next to calcium?
Oh, so there's no parentheses here. Why? That's a good question. I put a parentheses here for chromium, but why do I not need to put a parentheses next to calcium? Yeah, go ahead. Calcium's not a transition metal. So chromium is a transition metal. So chromium could form either a +2 or a +3 charge. You don't have to memorize if it's a +2 or a +3, but it doesn't always form the same charge. No? The Roman numeral 3 is because chromium has a +3 charge. So let me go back to this slide here. Chromium could either be a +2 charge or a +3 charge. So we put the Roman numeral 3 to specify that we made chromium sulfate with a +3 ion, not the +2 ion version. Okay? Make sure that's where things start getting a little confusing. Transition metals, they can form different ions. Okay? You don't need to memorize these. All right? I would have to specify. I would have to specify, and you'll see this when you look at the formative for today. I would have to specify, if I'm going to ask you, what is the chemical formula of chromium 3 sulfate, I have to specify the 3. I would have to say chromium 3 sulfate. If I just said, what's the chemical formula of chromium sulfate, like what we first did, there's 2 possible answers to that, because I didn't specify the +3 ion on chromium. Okay? Yeah.
So it says the chromium 3, then it's a +3 charge?
Yeah, it's saying that this chromium has a +3 charge.
And if it said like negative, is it negative from here?
No, the other option would be chromium 2.
Oh.
And then that would be let's do that one actually. Let's say we had chromium 2 sulfate. Think through, like on your paper, think through what the answer would be. Chromium 2 sulfate, what would be the chemical formula of that? I did it again. Chromium 2 sulfate. It's very easy to forget the Roman numeral 2, but it is wrong if you don't specify that too. Chromium 2 sulfate. Well, chromium, we know that's Cr. The 2 says that chromium has a +2 charge. Sulfate, that's SO4. And what is the charge on sulfate, SO4? -2. Charges have to balance to 0. So they balance to 0. So chromium 2 sulfate would just be CrSO4.
Without parentheses.
No parentheses, yeah. Because you don't need a second sulfate. You don't need to change the number of sulfates. Okay.
You don't put like the 2 for the chromium?
Nope, the 2 here, you only put the 2 in the full name.
Oh.
Because whenever you're doing these, think back to like last class. Like if you had like NaCl, that we assume the charges. Like only if you're like trying to show your work or solve it would you put the +1 -1. When you actually write out the formula, you just say NaCl. Okay. All right, I think I got some more practice ones on the next slide. Yeah, let's do some other practices here. All right, so iron and 3 irons and 2 phosphates. So try to think through what the name of that would be. First thing you got to do is you have to know, well, what is the charge on phosphate? Trevor, what's the charge on phosphate? -3, okay. You know phosphate is a -3 charge. Looking at iron, iron is a transition metal. So you don't know the charge on iron, but you do know the charge on phosphate. And that 2 there, that's telling us we have 2 phosphates, 2 -3s. The charges have to equal 0, and I have 3 irons to get me to 0. Each iron has to have the same charge. So it's basically saying 3x -3 -3 equals 0. If you want to think of it that way. 3x -6 equals 0. What would x equal?
2.
Yeah, you plus 6 to both sides. So you got 3x equals 6. Divide both sides by 3. X equals 2. So x equals 2. That's telling me that each of my 3 irons would need a +2 charge. Because then you'd have 2 + 2 + 2 is 6. minus 6, that gives you 0. Okay? So then the name for this would be iron, not iron phosphate, iron 2 phosphate. You got to specify the 2 there. Iron 2 phosphate. Okay? Why don't we, I'll put up the answers to the other ones. I want to make sure you have time to do your formative. So here are the answers to the other ones. You can copy them down for your notes. But you can go ahead and move to doing the formative. You can cross off 5 and 6 from your notes. You can just put a line through them because they involve cyanide and chlorate. Those are 2 polyatomic ions you don't have to memorize. So you don't have to do those 2. But the other ones like 7, 4, 3, and 2, those would be just some other examples that can help you out. You know, that would be valid, like questions I could ask you on the on your test. Whenever you're doing the formative, like if I'm gonna write if you're gonna write iron 2 phosphate as an answer in formative, go ahead and write it all without spaces. So write it like that for like answer key purposes. Jonathan, yeah.
So if there was like 1 iron, would I have to say iron 1 phosphate, or would that be
So the just to be sure I understand your question, the 2 isn't saying the number of irons. The 2 is saying the charge on each iron. Does that make sense? Yeah, Kelly?
Did it say V2SO4?
V2SO, oh, I'm sorry, you can cross off 4 too. My bad. Sulfite, that's another polyatomic. You don't have to know that one either. So 4, 5, and 6, those are examples that you wouldn't be tested on. You could look at them for practice. It's the same idea. The charges balance out, but you don't have to memorize sulfite. And then the last thing, if you're going to write, say you're going to write Fe3PO42 in formative, you would write it like this. Fe3, just keep it on the same line, parentheses PO4, and then a 2 all on the same line. Okay? No? The formative, I give you both ways. Like I'll give you maybe the name, and you either give me the formula, or I give you the formula and you give me the name. Okay. All right. Let me stop this.